Okay, so in today's video, we're going to look at some basic analysis in SPSS. Okay, usually some people prefer using R and Python, different software. I think it depends on the type. For me, basically, as far as my knowledge, my skills in software go, I use SPSS for some of my basic analysis. Okay. So today, first of all, what we're going to look at is to look at transforming. Okay, you have data and you want to transform it. Okay, so say the data was not numerical and you have to transform it to be able to do your analysis. Say you want to do something like regression or um, yeah, so something like regression or correlation. So okay, so we're going to look at transform first. Okay, so we want to transform our work um, from a non-numerical variables to or data type, non-numerical data type to something numerical, which will allow us to run analysis, either as regression or correlation or any form of statistical analysis you want to embark on. Okay, so to do that first, I'm just going to import my data. That's going to take quite some time. I should have done this, but you go to this and import. I'm just going to work on Lagos, the city of Lagos. So this may take me some time. I think it depends on how fast your laptop runs. And okay, so I'm going to add this, and my output is still running before um, the data actually comes. It's presented in SPSS in the spread. Should I say the spreadsheet? Something like that. Okay. So it's still running. Let's just give it some time. Oh, sorry. So here we go. The data is in, and what we're going to do is to transform this data. Okay, so we'll go to the data variable. Oh my goodness, variable view rather. We have the data type to be string, and we don't need it that way. We need something numerical to run our analysis. So what we do is to go to transform and go to automatic code recode. Sorry. Okay, so what we're going to do is we're going to recode every one of these variables. Okay, so you're going to drag or drop something like this, or you use the arrow to drag and drop. Sorry, or use the arrow to place it in a new. Is it tab? Let's say box. Now we're going to assign new names to this. So this is 7 groups. I'm just going to call that 7 groups. But one thing you should note is SPSS doesn't allow spacing, so we use underscore. So when that's fully entered, you go ahead to add it. Sulfur. Okay, so sulfur mostly there are two spellings. The US goes with the US spelling goes with F, and the British go with PH. But me, as a Ghanaian, I usually use the PH. We often use a British spelling compared with the US, even though we mix them separately. But in this case, I want to type something fast. I'm just going to go with the US. Sulfur dioxide. I hope I get all the spellings right. Now add this particulate matter, PM. So let me use matter. One thing you should note is if the new spelling has the same, sorry, the new name has the same spelling as the initial one, it's not going to accept that. So you have to consider that. The nitrogen dioxide, for this one, it's just one spelling. There is no British and no US spelling. So nitrogen dioxide and carbon monoxide. We go with the carbon underscore monoxide. Air temperature. Should I spell that fully? Okay, so let's see temperature. And ozone gas, it goes with O3, so ozone. Sorry. So when this is done, you go ahead to click OK. And it's going to recode it. So the old values were just a string, so there were no any numerical values attached to it. So we had something like urban growth dynamics and vegetation and water bodies. But when it comes to the recode, what we transform, it tells us the new values are 1, 2, and 3, where 1 is for urban growth dynamics, 2 is labeled as vegetation, and 3 is labeled as water bodies. Okay, so it goes the same way for the atmospheric chemistry indicators and the same as the aerosol. So it arranges everything as the software kind of command. So we have to kind of change that. In this case, I don't want the high, sorry, so I don't want the load to be 2 and the mean to be 3. I want the mean to be 2 and the load to be 3. So we have to change that. Okay, so when you come here, I don't actually need these guys. After transforming, I don't need them. So I'm just going to clear them and I'm left with this. Okay, so now they are numerical. So when we go to the variable view, you can see the data type is now numeric instead of the initial string we had. Okay, so you can, maybe the labels, you can go ahead. I'll just let this be like, I'll call this land cover, something like this. And this guy is going to be SO2, should be labeled at PM 2.5, sorry, not 4. And this guy will be NO2, nitrogen dioxide. This guy will be carbon monoxide and CO. This is air temperature, so maybe something like this will maintain that, and ozone will be O3. Now to the values, you realize that, okay, so when we check, as we check it initially, maybe we're okay with this, we're not going to change anything. That's fine. Okay, so when it comes to the other thing, what I'm basically going to look at is to look at the relationship between the association between urban growth dynamics and air quality. So I'm assuming that when there is a change in the urban land cover, which favors more the built-up areas or the impervious surfaces, then the air quality of the area is going to be reduced. In this case, I'm looking at Lagos. Okay, so these are the indicators I actually use for my analysis, ranging from sulfur to ozone gas. So I'm going to ensure that these things are properly representing what I want, as we discussed initially. So I'm going to ensure that I change these. Okay, so this is represented as the mean, number 3, as the value is 3. I'm going to change that to something 0. I want to completely change that to fit my arrangement how I want it. You can change it either way you want. So this guy is going to go by 3, and I'm going to give him the number 2 at this time around. So I have it set. You have to run the same thing for everything you have, if that's how you want it. So you make sure you change everything to fit whatever you want. I think maybe there might be a way you might want to do yours, but that's it's solely dependent on the requirement of your assignment. So this is gonna go for 2. Go ahead. So I'll do that for this guy. In this case, this guy goes with 2. I think I'm sure there was an empty within the data set. There was a place that was quite empty, so that place kind of created this gap. So I'm just going to give this guy okay, so this guy, I'll give him number 1, and I'll change this to 2, and that's it. I have it arranged the way I wanted it. You go ahead with this guy. I'm changing him to 0, and I'll go with 3. Then he goes with 2. You click OK. We have 2 more to go, so this goes with It goes for 0, and that goes for 3, and he goes for 2. My goodness, not this. So he goes for 2. That's it. The last one goes for 0 and 3 here. That's right. So, okay, that is changed, and this goes for 2. Okay, I'm not using a mouse, I'm using my pad, so you hear that sound. Okay, so after the transformation, I've kind of edited everything the way I wanted. Now, we want to run our analysis, we want to look at. So let's look at multinomial analysis, multinomial logistic regression, sorry. So I'm assuming that the association between these variables is going to be flat, as it's going to be straight, okay, so no bend, no curve. I'm saying when there is that change, there is a linear change, and the land cover, which ways is skewed towards the built-up area or impervious surfaces, then that is going to negatively affect the air quality in the area. Okay, so I want to statistically validate that. Okay, where my hypothesis, I'm assuming that there will be an association which would have, significant statistical significance. Sorry. Okay, so we just do that by going to analysis, and here you have several options to explore based on your assignment or your study purpose or aims. So I'm going for regression, and in this case, I want to do multinominal logistic regression, so I get that selected. Okay, so now I'm going to look at we're going to look at which is supposed to be the dependent and which is supposed to be the independent. Okay, so my dependent variable is basically, in this case, is urban growth or the land cover, okay, which is looking at a change in it is going to affect the others. How is it affecting air quality? So when you sum up all these atmospheric chemistry and aerosol dynamic indicators, it gives you the air quality. Okay, so a change in this, how is it going to affect them? So I'm going to put it and say, is there a way it's going to affect it? Let's see whether that's actually true. So sorry, I'm just going to take Control A and highlight it. So you just select one and use Shift to highlight everything. Then I add that to the covariates. Okay, so I basically want to change this from the last to first. So you go ahead to the reference category and you go to first. Okay, so the module, we go ahead to see what we can change. Nothing actually here, but the statistics have to be clearly looked at. And here it depends on your assignment. What do you want to consider at the output? So for me, I think I'm going to add the goodness of fit to this. And I'm okay with the other ones already selected. But if you want to add any other thing, you can go ahead to add it. So let's say we want to look at the monotonicity measures. Then we got that selected. If you want to check any of these other parameters, you go ahead to select that. But if not, you just go ahead to continue. For the other things, maybe you can check the other things. We can check other ones. Okay. And just get over here. Okay, so I don't have to change anything here. Neither do I want to change anything. The bootstrapping, I'm not changing anything. So I'm okay. So you just go ahead to click OK. And the results are running down there. And let's hope it comes successfully. Okay, so here come our results. And you have the case processing summary that's presented. You have the module fit information, the goodness of fit is here, the pseudo R square presented, the likelihood ratio test. It goes all down to the parameters you selected. Everything is quite presented down here. Okay, so what you do next is just to save this and you interpret it based on your hypothesis. So you go ahead to right click and go to export, and you save it as what you want to save. You navigate to whichever file, or wherever you want to save the work, and you go ahead you go ahead to click OK. Okay, so when everything is set and done, you go ahead to click OK, and that will be it. I already have something saved in that same area, and I don't want to save a duplicate file, so I'm just going to get that off. Okay, so when that is done, you interpret it based on your findings to see whether it will validate your based on your hypothesis, whether it's going to validate your null hypothesis or your alternative. Okay, so that's basically how you run your multinomial logistic regression, and I hope that will be very helpful in your work. It'll be helpful in your assignment, and I hope to see you in the next video. Do have a good time, Whether it's going to be evening, afternoon, morning, or night. It's 5 here in Ghana. And I wish you all the best. Thank you.